PreCalc, we are moving on to the 2-2 Day 2 notes, which can be found in the folder on Canvas entitled Calculus Chapter 2, or you can do this on your own paper. We are doing limits involving infinity. So all of these limits that we're going to kind of deal with are going to be the limit as x approaches positive infinity or negative infinity. Before we get to that though, we're going to talk about something called a right and left end behavior model. So you're going to be finding a right end behavior model and a left end behavior model. Basically what's going to happen is for this function we have f of x equals x plus e to the negative x. We're going to find the left end behavior. So basically what we're finding is what does the left half of the graph look like? All right, and the right end behavior is looking at the right side of the graph and determining what that's looking like. And we're going to be writing them as an equation. So if it looks like, you know, it's following that of like an x cubed graph, the equation might be, you know, f of x equals x cubed or whatever it is. All right, so let's look at this. The left end behavior. All right, what's going to happen is it's basically as we go to negative infinity. The right end behavior is as we go to positive infinity. For these left end behavior models and right end behavior models, typically the problems are going to look something similar to this. And when you're adding two things together, you're going to have a 50-50 chance of getting these equations right, because the left end and the right end behavior model are either going to be the x or e to the negative x. All right, it's going to be one of those two, whichever is getting bigger faster. Whichever is getting bigger faster, that's the one that's going to kind of win out, and that will be our end behavior model. So as we go to negative infinity, okay, what we're basically doing is, let's say that we have f of x and we're plugging in negative infinity for x. We're going to have negative x plus e to the negative infinity. I just replaced the x's with negative infinities. And then we're going to look at both pieces and say, well, which one's getting bigger faster? Well, if you look at this piece, that's negative infinity, so that's getting smaller. This becomes e to the positive infinity because the negatives cancel. This is getting bigger and bigger and bigger. You're raising it to the infinity power. So this is getting bigger faster. That's the one that's going to win out, and that's going to be our end behavior model. So the left end of the graph is going to follow, and I'm just going to call this g of x. We don't want to call it f of x because that's f of x. So g of x is going to equal the right side, or this piece here, e to the negative x. All right. So the left side of the graph would follow whatever e to the negative x looks like as a graph. I'm not exactly sure off the top of my head. The right end behavior is going to be as we go to infinity. So what you're going to do is you're going to plug in infinity now instead of negative infinity in for x. So we've got positive infinity minus e to the negative infinity. All right, so we got to figure out which one's getting bigger faster. Well, e to the negative infinity, that's the same thing as saying 1 all over e to infinity. All right, 1 over something really large is going to be approaching 0. All right, 1 divided by 2 versus 1 divided by 3 versus 1 divided by 4, 1 divided by 5, 1 divided by 6. It's getting smaller and smaller and smaller. It's getting closer and closer to 0. This is infinity. That's a really big number. So this one's the one that's getting bigger faster. All right, so this one's getting bigger faster. And because that one's getting bigger faster, that's the x piece. So the right end behavior model is going to be g of x equals x. Okay, we'll usually use g of x for our end behavior models. All right, so that's kind of how you can tell. And so that's kind of how that works out. Let's see. When we do number 2, Number 2 says use the graph of y equals f of 1 over x to find the limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x. The main important thing to know that will help you in this particular problem is a couple things. The one thing to be aware of, okay, and this will help you later on, is the limit as x approaches infinity of f of x is going to be doing the same thing as the limit as x approaches 0 from the right side of f of 1 over x. All right, and for negative infinity, limit as x approaches negative infinity of f of x is going to be the same thing as the limit as x approaches 0 from the left side of f of 1 over x. Okay, so this will be important for you to know, and we'll use that to help us because they want us to use f of 1 over x. So if we find the limit of f of 1 over x as x approaches 0 from the right, that'll be the same thing as the first thing they want us to find. And then the second piece will be the same as this piece. So that's what we're going to do. When you do these problems, you can do these with the graphs or without the graphs. It just kind of depends on what you have. With A, I'm going to use the graph. B, I'm going to do it without a graph, just so you kind of get the main idea for both. All right. For part A, if you were to graph this thing, okay, and I'm talking about graphing f of 1 over x. All right. So if you were to graph, instead of x e to the x, if you were to graph 1 over x times e to the 1 over x, if you were to graph that on your calculator, here's just a basic sketch of what this thing would look like. Okay, the right piece would look something like this, and the left piece does something like this. Okay, so that's what this graph would look like. And so what we're going to do is we're going to find the limit as x approaches 0 from the right side of f of 1 over x. And we can do that just by looking at the graph. All right, when we do that, that's going to be the exact same thing as finding the limit as x approaches infinity of f of x. And then that'll give us our answer. So if we look at as we approach 0, okay, so we're talking about this piece in the middle here. As we approach 0 from the right, we're going up this piece and going up, 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 which means that we're approaching positive infinity. So the answer for that one's going to be positive infinity. The limit as x approaches 0 from the left side of f of 1 over x will be the same thing as finding the limit as x approaches negative infinity of f of x. All right, so let's approach 0 from the left side. All right, if we approach 0 from the left side, we're looking at this branch down here. As we go up this branch and go up, 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 we're getting closer and closer to the origin, which has a y value of 0. So the limit's going to end up equaling 0 for that particular one. All right, so that's where you can use the graph. B, there is a typo. We're going to get rid of the squared here. Okay, so it should just be, oh, and the sign should be squared. So it should be x squared sine squared 1 over x. I apologize for the typo. We're going to do this one without looking at the graph, just to show you how you can do it. All right, so let's look at f of 1 over x. F of 1 over x means we're going to replace all of these x's with their reciprocal. Instead of x squared, it'll be 1 over x squared. All right, times, and then we still have sine squared. And then we're going to replace the x with 1 over x. Well, if you have 1 all over 1 over x, that's going to equal x. All right, so we really end up with sine squared of x. And what I'm going to do is multiply those together. I get sine squared x all over x squared. All right, and then what I'm going to do is I'm going to split this up a little bit. This is the same thing as saying sine of x over x times sine of x over x. Sine of x times sine of x is sine squared of x. X times x is x squared. All right, so then what we can do is, if you recall on our last note sheet, when we did this, all right, we're trying to find, by the way, the limit as x approaches 0 from the right and 0 from the left. All right, so we're going to be doing the limit as x approaches 0 from the right of sine of x all over x times sine of x all over x. Well, when we did this on our last note sheet, the limit as x approached 0 of sine of x over x was equal to 1. I don't know if you remember that or not. So we're doing really 1 times 1. It's going to end up equaling 1. All right, so the limit as x approaches 0 from the right of f of 1 over x is going to be the same thing as the limit as x approaches positive infinity of f of x, and that's going to equal 1. All right, and then the same is going to hold true for when we do the limit as x approaches 0 from the left. All right, the limit as x approaches 0 from the left of sine of x over x times sine of x over x. It's going to same thing, it's going to equal 1. So the limit as x approaches 0 from the left of f of 1 over x is going to be the same thing as the limit as x approaches negative infinity of f of x, which equaled 1. So both of those ended up equaling 1. If you don't want to do it that way, you could look at the graph. Graph this thing on your calculator and then look and see what the ends of the graphs are doing. Actually, what we're doing as we approach 0 from the left and the right. Okay, let's look at number 3. Number 3 has several pieces, and you'll notice this is a piecewise function. So we're going to be, first of all, for part A, we're going to be finding the limit as x approaches negative infinity of f of x. Now, when we do that, we're going to be looking at the left side of the graph. The left side of the graph would be this piece, because that's less than 0. So we're talking about 1 over x squared. Okay, so we're doing the limit as x approaches negative infinity all over 1 over x squared. All right, and if you remember when we did this, if you did like the limit as x approaches infinity of 1 over x, all right, that ended up approaching 0. All right, the other way to think about it is you're doing 1 divided by a really large, granted it's negative, but it's 1 divided by a really large number. All right, technically you're doing negative infinity squared. So it's the same thing as 1 all over infinity. When you do 1 divided by really large numbers, all right, think about like 1/2 versus 1/4 versus 1/10 versus 1/100th. As that number gets bigger and bigger on the bottom, you're getting closer and closer to 0. So this limit is going to approach 0. There is a horizontal asymptote at y equals 0 for that branch of the graph. For B, the limit as x approaches positive infinity. That means as we go to the right, which we're going to be looking at this piece here. So we're going to be doing the limit as x approaches infinity of x plus 4 all over x plus 5. Now if you wanted to, you could graph this thing. Okay, you can tell that this graph is going to have a horizontal asymptote, all right, because the degree on the top is the same as the degree on the bottom. The horizontal asymptote is 1. You could also graph it and see that this thing is approaching 1. The other way to think about it is if you plug in infinity, you're going to have infinity plus 4 all over infinity plus 5. Well, adding 4 or 5 to a really large number isn't going to make much of a difference. So essentially you're doing infinity divided by infinity. Infinity divided by infinity is going to be 1. All right, there is a horizontal asymptote at y equals 1. And you could graph this if you need to. You'll see that there is a horizontal asymptote, and as you go to the right, it approaches 1. So if you need to see the graphs, graph it. Go for it. For C, we're doing the limit as x approaches 0 from the left side, all right, of f of x. And the left side is going to be this piece here. So we're really doing the limit as x approaches 0 from the left side of this 1 all over x squared. All right, we can't plug in 0 because, once again, it is going to make it undefined. All right, but what you can do is, remember we did this on our last problem, we can just let x equal something really close to 0 from the left. So let x equal maybe negative 0.99. If you do that, you're going to end up with 1 all over negative 0.99 squared. All right, you're going to end up with a positive over a positive. All right, and so that we know it's going to end up equaling infinity. All right, we know that because there is a vertical asymptote at 0, that's not going to cross the vertical asymptote. It's either going to approach positive infinity or negative infinity. So we plug that value in to see what we end up with, and we get positive infinity for that. And then D, we're going to do the same thing, except it's going to be the limit as x approaches 0 from the right. All right, I'll finish this up in the next video. Alrighty, thanks.